Hello all, welcome to my channel. So today I would be continuing with the last part where we left. So in this we would be starting with electric field on equatorial line of an electric dipole. So in this case again I have drawn an electric dipole. As you know, in electric dipole we have two opposite charges and they are of same magnitude. Now in this case they are separated again by a distance of 2a, that is length of a dipole in this case again is 2a. Now it says equatorial line. Equatorial line basically means if we have a point O on a electric dipole, then we should make a 90-degree angle with respect to electric dipole. Then mark it as point P. Then just draw PA, join PA and next join PB. Now as you can see, A charge is negative, so it will be the electric field will be radially inwards. So the direction for EA will be radially inwards. Now if we talk about point B, it is positive charge, that means it will be radially outwards. So the direction of this will be in this direction, that means EB is in this direction. And next is we need to find the magnitude E, that is the total charge. So it will be like this in this direction, and here we can apply triangle law. So joining E and EA and EB. So you can see we have a parallelogram here. So mark it as point M here. Let this be N here, and EA on the line EA, let it be L, and this is P. So MPLN is a parallelogram. Now I would be writing EA, that is along PA here. So EA will be 1 over 4 pi epsilon naught. Then you have Q and then you have distances AP square. Now here we need to find AP. And remember, I am taking PO as R. The distance between P and O is R. And distance between A and O is A here because it has been bisected. Now we need to find PA. So PA by Pythagoras theorem will be under root of R square plus A square. Now if you want to write AP square, it will be only R square plus A square. So 1 over 4 pi epsilon naught Q over R square plus A square. This is along PA. Now again EB. EB will be written as 1 over 4 pi epsilon naught Q over PB square. So PB square is similar, that is R square plus A square under root. So 1 over 4 pi epsilon naught over Q over R square plus A square. So as you can see, E and AB have same magnitude. Now we need to find the resultant electric field, that is E, vector E. So how to find that out is as you can see here, we have a triangle law of addition of vectors. So according to that, we have to use the identity of it. So it says vector E, vector A, then vector B. With respect to vector E, we have BA. Let me show you. With respect to vector E, we have AB. With respect to vector EA, we have, this is EA, so we have PA for it. And for vector EB, we have PB for it. Now according to this, we can easily find the value of vector E. As they are all similar, so we will be writing vector E equals vector EA, then you have to multiply it with BA over PA. because I am using these two quantities. So you have to use cross multiplication to find the answer. Now, as you know, EA is 1 over 4 pi epsilon naught Q over R square plus A square into BA. BA in this case is twice of it. The distance between the dipole is 2A over PA. PA in this case is under root R square plus A square. So you can write R square plus A square raised to power half. Now we have 1 over 4 pi epsilon naught Q twice of A. Then we have R square plus A square. So as R square plus A square has same base, so their powers are different. So we can add the powers. So it will be 3 over 2. Now in this case, as you can see, we have Q into 2A, which can be written as dipole moment. So it will be 1 over 4 pi epsilon naught P over R square plus A square raised to power 3 over 2. Now in this case, if I say that my dipole is of very small length, that means my A is very small as compared to R. So in that case, we have to ignore this part and we are left with 1 over 4 pi epsilon naught P and R square raised to power 3 over 2, which is 3. So it will be 1 over 4 pi epsilon naught P R cube, which is our electric field if my dipole is of very small length. And this is again dipole moment, electric field on equatorial line of an electric dipole. Now next is electric dipole in uniform electric field. Let's study about it. So in this case, we would be talking about electric dipole in uniform electric field. We have electric field which is uniform. Now in this case, we first of all draw uniform electric field. Let us draw uniform electric field. And now we have to draw dipole in it. So suppose we have a positive Q charge here and a negative Q charge here. So the direction of electric field is in this direction. So force will be in this direction for positive Q. Now for negative Q, it will be in this direction. That will be minus Q E. Now the difference again is of 2A. Here we have angle between minus Q and plus Q. We have theta here. Mark it as N here. Now we have dipole momentum P. If this is theta, then this will be equal to theta. Alternate interior angle property. So first of all, you will write force on charge minus Q. So it will be minus QE. Now force on positive Q. It will be positive QE. This is along E. Electric field is in this direction and force on minus Q is in opposite direction to E. And this is in same direction. Now we need to find the electric dipole under uniform electric field. So the torque in this case is written as force. You can take either of them. Either force into perpendicular distance between two forces. Now I would be prefer to take force positive one QE and the perpendicular distance between the two forces is, I will mark it as A, so it will be AN. Now we need to find the value for AN. So it will be QE. This we need to find by the help of trigonometry. So as it is 2A and this is theta, so my AN will be 2A sine theta. So putting the value of AN here, that is sine theta, 2A sine theta. Now we have Q, we have 2A, we have E sine theta. So Q2A, as you know, can be written as P. So it will be P E sine theta. This is equal to torque. Now, if you want to write this in terms of vector quantity, vector notation, so it will be torque equals P cross E. So this is electric dipole moment. P is a vector from charge minus Q to positive Q, and this equation is represented in the vector form, that is torque vector equals P vector into cross E vector. So this is how you denote torque under uniform electric field. So that's all for electric dipole in uniform electric field. So this is the last topic of electric field and charges. I would be starting with the next chapter. So thank you for watching this video. Have a great day.